Let's take a look at the try one more. Find the area of the shape below. How did you find the area of this shape? Say it out loud. I heard some scholars say that they noticed that the width of the figure was 6 centimeters and that the length of the larger figure was 6 centimeters. They noticed that there was a cutout at the bottom, but that if the cutout wasn't there, they would have a full rectangle to solve for the area. Without this cutout piece, imagining it was actually here, what would the area of the large rectangle be? Evaluate. That's right. We can multiply the length and the width in order to find the area of the large figure before we cut out the part that we don't have. What would the area of this large rectangle be? Yes, 6 times 6 equals 36 square centimeters. Great job. What do you notice about our larger shape? Say it out loud. Correct. We had to draw lines to fill in the cutout part. Sometimes we will have the larger shape and the cutout will be within the shape, and sometimes we will need to extend the shape to create both the cutout and the larger shape. What did you do next to solve this problem? Say it out loud. Right, since we don't need the area of the bottom part within our larger shape, we want to find the area of the small rectangle at the bottom. And subtract it from the area of the larger rectangle. What was the area of the small rectangle that you want to cut out? Say it out loud. Great job. We want to multiply the length, which is 4 centimeters, and the width of the small rectangle to find the area. What is the area of the small cut out rectangle? Yes, 4 times 2 equals 8 square centimeters. Wonderful. How did you find the area of the original shape? Say it out loud. Good. We know that the larger rectangle has an area of 36 square centimeters. And we want to subtract the cutout part, and the area of the cutout part is 8 centimeters. And 36, take away 8 equals, yes, 28 square centimeters. So the area of this cutout figure is 28 square centimeters. Wonderful work. What is one longer equation that I could write to represent this problem? Say it out loud. Right. We can write 6 times 6, which represents the area of the larger rectangle, and subtract 4 times 2, which represents the area of the smaller cut out rectangle, equals A for area, where 6 is the length and width of the larger rectangle, and 4 is the length and 2 is the width of the smaller rectangle that we're cutting out. And A stands for area. Great job creating a longer equation to represent the work and the steps that we took to find the area of this shape. How is what we did in this problem the same and different from what we did in the problem of the day? Say it out loud. Yes, in both problems, we found the area of the given shape by first finding the area of the larger shape. We then found the area of the cutout shape and then subtracted the cutout shape's area from the area of the larger shape. In the first problem, we had the larger shape and the cutout was already given to us in the middle. In this problem, we needed to extend the rectangle to make it work. As you continue into your workshop, let's keep these steps in mind.